Alright, let's look at the homework 3.2, problem number 6. Alright, so let's look at part A. We have f of x equals x squared minus 1 over x squared plus 1. Then we want to find the first derivative and the second derivative. Alright, so let's do that. Alright, so first derivative. So if you take the derivative, so f prime of x is equal to, so we have to square the denominator. So you have a quantity x squared plus 1 squared. Right? Take the derivative of the top, which is 2x, and times the bottom, which is just x squared plus 1, minus top, which is x squared minus 1, and then times derivative of the bottom. That's going to be 2x as well. So we have that. Alright, then we can simplify this since you have two x's in common. So we have 2x here and 2x there. We're going to pull that out. Alright, and the denominator stays the same. So you have a quantity x squared plus 1 squared. And the 2x is factored out. And then what's left is going to be, let's see, so you have a 1 minus, actually x squared minus x squared. So those cancel out. Then we have 1 minus negative 1, so that will be 2. So it's actually, instead of 2x, maybe I should write it as 4x because it's times 2. So I'm going to write it as times 2. So 2x times 2, so it's a 4x. Alright, so it's the first derivative. So I'm going to go ahead and type that in first. Alright, so you have 4x over quantity x squared plus 1 squared. Alright, and then we take another derivative. So f double prime of x is equal to, alright, first we have a constant here, so this is a constant multiple. I just put 4 in front. Alright, then we just take the derivative of the rest. So square the bottom. So we have a quantity x squared plus 1. It was already squared. It's going to be a fourth power. Right? And derivative of the top is 1 times the bottom is quantity x squared plus 1 squared minus top is x multiplied by derivative of this guy, right? So derivative this guy takes up, maybe we have to maybe multiply out a bit, all right? So derivative of this is going to be, all right, so if you multiply out, you have x to the fourth plus 2x squared and plus 1, all right? Then we have to take the derivative of that, so it's going to be 4 x cubed, right, and plus 4x and plus 1 derivative, 1 is 0, right? Then we need to do a little bit of cleaning up, so you can see that, let's see, there's still 4 there, all right? Then here, alright, this guy, if you pull out 4x, then you see that you're going to have x squared plus 1. Alright, so we have a common factor. So there's x squared plus 1 here. There are 2 of them, so I'll circle this guy. And there's x squared plus 1. So we can pull that out. So we have x squared plus 1. Those will pull out, and then what's left is going to be here. So there's another x squared plus 1 from the first term. So we took care of this guy already. All right. Then we still need to take care of, there's a negative x here and also 4x, so it's going to be negative 4x squared. So minus 4x squared. Alright, then you have x squared plus 1 to the 4th power. Alright, then we can cancel. So you can see that there's an x squared plus 1 on top. They're actually 4 of those. So I'm going to just scratch 4 and put 3 because one of them cancel out. Alright, then we can just clean out a little bit. So you're going to have a 4 on top. Alright, so there's 1 minus negative 4x squared, and the x squared will be negative 3x squared, and over x squared plus 1 cubed. Right? So let's type it in. Alright, so it was 4. Alright, 1 minus 3x squared, then divided by x squared plus 1 raised it to the 3rd power. Actually, there might be x there. Oh, actually, x is, let's see. Oh, x is not there, sorry. Alright, so I think this is okay. Alright, so let's go ahead and check the answer here. Alright, submit for testing. Alright, it came back and that we have done part A correctly. Alright, so let's look at the part B. Alright, check to see that your answer to part A are reasonable by comparing the graph of f and f prime and f double prime. Alright, we can't do that unless you type it in the calculator or GeoGebra, but I think we can answer this question. If f prime is equal to 0, then f has a horizontal tangent line, right? F double prime is equal to 0. F prime has the horizontal tangent line, right? F prime is negative, which means that the f is decreasing, right? Positive, then of course it's increasing, right? F double prime is negative, then f prime is decreasing, and positive when f prime is increasing, right? F prime is negative and f is concave downward, and if it's positive, f is concave upward. Right? So that's that. Let's see. Submit for testing. Alright, I came back and looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.